Hi, this is Sri Raghavamadugu. In this video, we are going to learn about decision trees, algorithms. So, before going into decision tree, let's try to learn what is a rule induction. So, rule induction it means learning general rules from specific facts or examples which is given. So, I would say it's a process of deducing if then rules from a data set. If the time is between morning 8 a.m. to 11 a.m. So the traffic in particular in one particular road is too high. So that's just a condition that I just applied using. I mean, so I'm if it's not that time, then the traffic might be low. So that is rule induction. So it is a process of taking millions of data points and replacing it with a model that represents these and future points, considering facts in the data. So it provides a powerful classification approach, and learning general rules means taking millions of data points and replacing them with a model. Decision trees are the implementation of rule induction. So let's see what decision trees are. Decision tree is one way to display an algorithm that only contains conditional control statements. These are considered to be one of the best and mostly used supervised learning methods. Before diving deep into decision trees, let's just get familiarized with some of the terminologies used here. The first one is root node. It represents the entire population or sample, and this further gets divided into two or more homogeneous sets. And the next term is splitting. So it is a process of dividing a node into two or more subnodes. And then comes decision node. So when a subnode splits into further subnodes, then it is called as decision node. And coming to leaf, it is also sometimes called as terminal node. Nodes with no children, I mean there is no further split, so then that node is called as a leaf or a terminal node. Now coming to pruning, so when we reduce the size of a decision tree by removing nodes, this process is called pruning, which is kind of opposite to splitting. Then comes branch or a subtree. So a subsection of a decision tree is said to be a branch or a subtree. Now parent node, a node which is divided into subnodes. Uh, then it is called as a parent node of those subnodes, and those subnodes are called as a child of that parent node. So let's move on to its working. So recursive partitioning is one of the coolest ways to implement tree induction algorithms. So all we need to do is a systematic method for taking a given dataset and splitting it once. Then we need to assume that each smaller dataset now is the actual dataset, and now using the recursive function, just reapplying the same systematic rule. uh, this is the working principle of uh, tree induction algorithm. Now coming to, so when we do this, when should we stop? When should the splitting be stopped? Then comes the question, why should we stop the splitting? So when we try to split to the most extent that we can, this leads to overfitting. So overfitting, this means that, say suppose we have tried to split to the maximum extent where each node has only one or two values. So now when there is a new test data, when we are trying to test it with the new data, then even with a slight change in the data, it is going to affect the outcome, right? So that is overfitting. So to in order to make sure it's not overfitted, we are supposed to find good spots where, so when to split and when to stop splitting. So first let's see when to stop splitting. A good split is one that creates good nodes as children. So we need to know the goodness of each single node. So how do we know the goodness of each single node? So we can calculate the goodness score of the nodes. It is p1 square plus or minus p2 square. So where p1 square is the probability of choosing a class A. Suppose there are two classes, class A and class B, or 1 or 0, if we consider it as a binary target variables. So suppose there are two variables, class A variable and class B variables as a target. So p1 square is the probability of choosing class A into probability. P1 square is probability that next item chosen will also be of class A, and p2 square is probability of choosing class B into probability that the next item chosen will also be of class B. So by this we can get the goodness of a node. Then what about split score? So how do we know the score of the split? So the split score is NL into score of the left node plus NR into score of the right node. What is NL? NL is the number of records sent to the left node, and NR is the number of records sent to the right node. So there is another, this is one option, finding the goodness of the node and goodness of the split is one option that we can choose to determine when to split. And there is another option, it's called Gini index. Gini index, Gini is equal to p square plus q square, where p and q are the sum of the probabilities of success and failure. And whenever the split takes place where the node that has higher Gini. Sometimes we also see Gini impurity when we talk about decision trees, and Gini impurity is 1 minus Gini, and this is equal to 1 minus summation of pj square. So all p1, p2, so on to pk are the probabilities in our nodes, and the k is the number of classes. Now coming to entropy. Entropy is a measure of disorder, and entropy is the formula is summation of minus p log p. When entropy is 0, then the split is good, and when the entropy is higher, the split is bad. And coming to variance, when are we supposed to take variance? So all the options that we chose, Gini, entropy, and split scores, those are very much feasible for discrete values. Like if there is only 1 and 0 class, or class A and class B, then that's fine. But when there's a continuous variable which is a target variable and which is continuous, then we can use variance here. And the split score here is something similar to what we saw here, the split score, just that instead of the score we are going to take variance of the left node and variance of the right node, and the smallest split score is chosen. That's all here what we needed to learn about the decision tree. In my next video we are going to take an example, a data set, and try to use classification model using decision tree using Python. Thank you.